So in 4.3, we're looking at the horizontal translation being added to our graph. We've already looked at the other graphs where we looked at the A value and we looked at the K value, and now we're just adding this H value. So let me review what we already know. If this A is negative, if A is negative, so that A value is negative, then it's a reflection in the x-axis. So as soon as the A value is negative, then it's a reflection in the a-axis. For example, if we had this, negative 2x squared plus 5, we would look right here and say, okay, the A value is negative, therefore it's a reflection in the x-axis, so it's going to be opening down. The next part we look at is we look at the actual value of the A, not looking at the negative. So just look at the value of the A. So it's a vertical stretch if the A is greater than, so if A is greater than 1. If A is greater than 1, we know it's a stretch. It's a shrink or compression, so we can say compression here, if A is between 0 and 1. So that means it's a fraction. So it's a fraction less than 1. Fraction or decimal. Fraction or decimal less than 1. So for instance, if I said over here, so let's do our two examples. I'm going to do y equals negative 3x squared plus 4 versus y equals, say, negative 1/3 x squared plus 4. So this negative here, the negative means that it opens down. So that would be opens down. So opens down, which is a reflection in the x-axis. Okay, so that means it opens down. So that's the negative. So the negative's taken care of by the sign in front. Then you look at the number, the actual number, and say, okay, but this is a 3 and this is a 1/3. If it's greater than 1, anything greater than 1, this one would be a stretch. So this one here is a stretch because it's a value of 3. So that would be a stretch. So that's a stretch. Then you say, okay, but the other one over here, this one here is 1/3, so it's less than 1. Anything less than 1, this is a compression. Compression, so compression or a shrink. So because of this value here and this one here, it's because of the actual value there. The negative is a separate thing. The negative is a reflection. It makes it open down, so it's a reflection in the x-axis, so it does this. So look at that separately, so don't look at that, and you just look at the value. So if the value is greater than 1, it's a stretch. If the value is less than 1, between 0 and 1, if it's anything less than 1, it's a compression. So compression versus a stretch. Okay, so we know that already. The new part that we're going to add to this section here is the horizontal translation. And that's this h value here. So it's the value that you're adding or subtracting to the x that is in the x squared. So it's in the bracket. So it's in the bracket with the x, in the bracket with the x. So see how it's in the bracket with the x, it's squared. That'll give you the horizontal translation. And it's always backwards, so I'm just going to note that down. So it's always going to be backwards, so the opposite. So say it's opposite. So I'm going to put a little star and say it's opposite. Okay? That's what that negative means. That means opposite of whatever that is. So for instance, if this one here, if it's going to be y equals x minus 2 squared plus 3 versus y equals x plus 2 squared plus 3. So what we're saying here is that this part here, this would move it right. So even though it's minus 2, you move this one right, and this one here, you would move this one left. Okay, so you take the opposite sign. That's why in the formula it says negative h squared, which means opposite of the h. So if it's a minus 2, you move it right, and if it's a plus 2, you move it left. So this is my horizontal translation. For the vertical translation, we already know this one from before. So the vertical translation is going to be if this last value here, so if you said y equals, say, x plus 2 squared plus 3, and y equals x plus 2 squared minus 3. So the vertical translation is the last value here, and this would be up, and this would be down. How do you know that? You look here at the sign, and if it's a plus, then it's up, and if it's a minus, then it's down. Okay, so then one more time, when we look at the formula, we're looking here at the k value. The k value, if it's a plus or a minus, if it's plus, it's going up. If it's a minus, it's going down. The h value is opposite, so it's opposite. This one's very tricky. Not tricky, but a little bit harder to remember. It's always the opposite. So it's a minus 2, I'm moving it right. If it's a plus 2, I'm moving it left. Here, you're looking at the a value in front. You look at the negative or the positive. If it's negative, it opens down, so it's a reflection in the x-axis. Reflection in the x-axis. If it's a positive, it opens up. You take the a value, and you're going to use the step pattern for that. Okay, so now we've kind of got it all established. So these are the parts of the y equals a x minus h squared plus k formula. So now, oh, and the next part that we want to do is, oh, let me just summarize it one more time. So for instance here, if I had y equals, so this is an example, y equals 3, say x minus 5 squared plus 6. So what we do is we look at each part separately. So the first part I would look at is I would say, okay, this is positive, so it opens, so no reflection. Okay, no reflection, it opens up. Okay, this part here, we're going to move it right 5. It's the horizontal reflection. So anything in the bracket with the x moves the x. So that means it's moving it left or right. So it's in the bracket. And that means it moves it left or right. So this, because it's minus 5, I'm moving it right 5. And then the last part that we learned here was this part here. So the number after it tacked on at the end, this will be up 6. How do we know it's up 6? Because it's plus 6. So we look at the signs, and that's it. Okay, and then this regular step pattern, which we're going to go over again when we graph it. Okay, so that kind of summarizes what that box did. And the next part here is just reminding you of how to find x and y intercepts. So to find the x-intercept, then we let y equal 0. And then here to find the y-intercept, you let x equal 0. Now what does that mean? And we solve that algebraically, right? So then we're going to sub in and we're going to solve. So what that means is that on a graph, so if we have a regular old parabolic graph, so say for instance something like this, we'll just draw a general graph. I'll have it opening down like this. Okay, then the x-intercepts are these pink ones here. So these are the x-intercepts. So that's this one and this one. We have 2 of them. And then over here in green, the y-intercept is this one here. So the y-intercept is this one here. So I'm going to highlight that. So the y-intercept is this point here where it hits the y-axis. So that's where it hits the y-axis, and the x-intercept is where it hits the x-axis. So again, the y-axis is the vertical, and the x-axis is here. So to find the x-intercept, we're finding it here where it hits the horizontal, these 2 pink ones here, and to find the y-intercept, it's right here on the y-axis. Okay, and we're going to just solve that algebraically by letting, for x-intercept, y equals 0, for y-intercept, x equals 0. So again, just a few pieces of information to know. The next one, the next 2 statements I have here is it possible for a parabola to have no y-intercept? So think about what I just drew here. So if I have a parabola, I would like to draw a parabola that does not have a y-intercept. So remember, that's what I just said. So I don't want it touching the y-axis. Is there any way you can draw a parabola so it does not touch the y-axis? Now, that doesn't mean that you're allowed to do this. So some people go, yeah, I'll make it really thin over here. But what happens here is that it keeps getting wider and wider. Eventually it will touch. It might not be here in the lower part, but it's going to eventually touch because it keeps getting wider. So even if you draw it really far to the right or to the left, eventually it's going to keep getting wider. And it might be way, way, way up here or down here, but eventually it will have to extend and reach the y-intercept. So at some point on this parabola, it might be further up, might be further down, but there's no way. Is it possible for a parabola to have no y-intercept? Nope. Okay, there's no way that you can't, that you cannot touch the y-axis eventually. Okay, so nope, it will always, always happen. All right. Now, the second question I have for you, is it possible for a parabola to have no x-intercept? So no x-intercept. So again, try to picture what that means is that I can draw any parabola I want. Is it possible for it to have no x-intercept? So remember the x-axis, excuse me, is here. This is x and y. And I want it not to touch the x-axis. So draw for me a parabola which does not touch the x-axis. Is it possible to draw one? So yes, you can. So you can draw it over here, facing up, and there's no x-intercept. So it'll keep going up, but it will never ever hit the x-axis. Or I can draw it below, facing down, and there's no way it would touch the x-axis. So yes, there's actually two ways you can draw a parabola so that it never touches the x-axis. So my answer would be yes. Yes, it is possible for a parabola to have no x-intercepts, but it's not possible to have no y-intercepts. Okay. And then what we're doing now is we're looking at some graphing. So in this, I'm asking you to answer a few questions. So we're going to sketch it. Sometimes we draw the grid for you, sometimes we don't, so it just depends. Sometimes we get you to set it up yourself. We're going to state the vertex, the domain, I did little blanks here, range, equation of the axis of symmetry, max-min value, any intercepts, and describe the concavity. You can actually answer all of this. So I said, note, it's possible to answer the whole question without graphing. You may have to estimate the x-intercept. Sometimes it doesn't hit nicely, so you might have to estimate there. But it is possible to answer the whole thing without drawing it all. So I'm going to do that. I'm going to answer all of these questions, and then we're going to sketch it. Okay, so let's answer all these questions. My parabola that I have here is this one here. It's x squared, x plus 1 squared. So if it's with the x-axis, if it's in with the bracket here, that means it's horizontal. So that would be a horizontal. So anything in with the x is horizontal. Okay, so that's what I'm thinking in my brain. Outside here, there's no value. So the invisible value outside is a 1. So if you have no value there, there is actually an invisible value of 1. So imagine, if you will, a 1 there, right? 1 times anything is there. So now, let's talk about the extra number at the end. So if there's no number here at the end, what you're doing is you're imagining it's plus 0. So although there's nothing in front, we know it's times 1, and we know there's nothing after, we know it's plus 0. So therefore, for my vertex for this is going to be, now my horizontal, remember, this is the new one we're learning in this section. It's always the opposite. So this means it's going to go left 1. So even though it's plus 1, it's actually left 1. So it's always the opposite sign. So for my vertex, it's going to be -1. So opposite, -1, left 1, and I didn't go up or down, so 0, 0. You must, and then this is, if you want to look at your formula, so if you're looking here at your formula, y equals a x minus h squared k, your vertex is always going to be hk. So that's what you're looking at here. And h means opposite of h, so negative h, and k. Oops, sorry, plus k. Okay, so it's always hk. So you get the value from here and here, and it's the opposite of this one. Now, what I'd like to point out is that for the vertex, you must put brackets. Okay? Otherwise, it's a list of values. You need to write this as a coordinate. So this has to be written as a coordinate. Okay, has to be written as a coordinate, x, y coordinate. So if you don't have the bracket, it's a list of numbers, not a coordinate. So you have to put bracket around this HK. Okay, so that's how we get this. So we know the vertex is -1, 0, which is where we get our HK. The domain, so for every parabola, now we know that every parabola keeps getting wider and wider forever and ever. We know my domain is going to be x as an element of real. So no matter what, x will keep getting wider and wider. The range, no, we look at this, and when we look at whether it opens up or down. So we know that this is going to open. For this one, look at the value in front. It's a positive 1, so I know it opens up. So in my brain, I'm thinking it opens up because it's a positive 1. So then if it opens up, and I know that my vertex is at -1, 0, but it's opening up, my range starts at the y value. So this here, we're going to get y is an element of real such that y is greater than or equal to 0. So it starts at the vertex. We always look here at the vertex. So we say, oh, okay, so that would come from my vertex. It's at 0 and it's opening up. So this is opening up, and we look at that for the range. Okay, the next question says the equation of the axis of symmetry. The axis of symmetry is always taken again here from the vertex. So this vertex gives us all the information. So it's going to always be wherever the vertex is, which is -1, and it's the x value, so that x equals -1. So it's an equation of the axis of symmetry. That's the halfway point for any parabola. So the halfway point, and I'll show it when I graph it. Now I need to point out this part. It's always the equation. So it always has to have x equals. So you need to always put the equation. Even if it doesn't ask you for it, you have to know it's the equation, x equals. And then the max or min value still from the vertex. The highest or the lowest point will always be from the y value. So this will always be y value. Okay, so take the y value from the vertex. Y value of the vertex is 0. And then that's going to be, is that going to be a maximum or a minimum? We know it opens up, so that's going to be the bottom of the parabola, so this will be a minimum. So minimum value is 0, so 0 minimum. Now, the x-intercept, so this is the x-intercept, this should say x-intercept. Oh, we want both intercepts. So here I want to do the x-intercept. So we're going to do an answer for x-intercept and also for the y-intercept. Okay, so the x-intercept and the y-intercept are just the x values and the y value. Let's see what they end up being. You could have 2 here or 1, etc. So let's do that from the graph. So let's answer that in a minute. Oh, concavity, here, it opens up. So we already did that one over here. So it opens up. I forgot that we had a line for that. So it opens up. So concave up. Some people just say up, right? You don't have to say opens up, but it's concave up. Okay, so when I graph this one, I need the vertex at -1, 0. So let's get a ruler. Sorry. So let's get a ruler at -1, 0. So I'm just going to do my axes anywhere you want, really, because this is not a big graph. We're just going to do here. And okay, so -1, 0. So this is y, x, and this is going to be 1 and 1. So this will be -1, 0 is my vertex. So -1, 0, which would be right here. So you're going to put your vertex right there. Now, for the rest of it, so that's -1, 0. The a value is 1. So in this case here, I know my a value. So my a value is 1, right? So its a value is 1. So I know my step pattern is going to be regular. 1, 3, 5, 7. Always the odd numbers. So from my vertex, I go over 1, up 1. So over 1, up 1. From that new point, over 1, up 3. And then I try to fit the 5 in, but I can't. So here, back left 1, up 1. Left 1, up 3. And you can see it's symmetrical around the vertex. That's my axis of symmetry. And if I do over 1 up 5, I can't fit it. Okay, but this is my parabola. So we're going to try to draw it with a bit of a curve to it. Like that. And don't go that too wide because we just want to keep it going straight up. Okay, there you go. That's good enough. So that gives us our vertex. And so then I'm asking you the x-intercept. So where does it hit the x-axis? Only at -1. And what's the y-axis? Y-intercept? It'll be at 1. So just you can answer that from the graph usually. Okay. Let's try that again. Okay, so it reviews the stuff from the previous section as well. So let's try it again. So we have over here, so the vertex is always from this value here. So this value here. The x value comes from the value beside the x and then the 3. So then I know that my vertex is going to be at 1, positive 1, right, positive 1, and 3. And we always do the opposite, right? So there it's the opposite, so 1, 3. The domain is always, always, always for every parabola going to be x is an element of real. So we don't have to worry about that too much. And then the range, it depends on if it opens up or down. So take a look here. It opens up. So concavity is up. So that means it's heading up. So it's going to be from the y value. Take the y value here, and it's heading up from the 3, greater than or equal to 3. So 3 and bigger. The axis of symmetry also comes from the vertex, and the vertex is going to be x equals 1. So that's my axis. So the axis of symmetry is always the x value. The range comes from here. The max or min value is back to the y value. So this will be y equals, so it's going to be 3 from the y value 3. And is that a maximum or minimum? It opens up, so that'll be a minimum. So it's heading upwards. It opens up, so it's going to be a minimum somewhere down there. The intercepts, I'm going to answer that after I draw it. Right, so I'm going to come back to this part here. So the intercepts, I'll come back to that in a second. So let's try to graph it first. So I'm going to graph it. I'm just going to put this somewhere in the middle because it's not a big graph. Like this. Okay, so this will be y and x. You have to label it and give me the units 1 and 1. This is very important that you label your x and your intercepts. Okay, same thing, x and your intercepts, and y, x and y and your intercepts. So you must label plus the scale, okay, because otherwise we don't know where anything is. So you have to always, always do that part.